Kosmos-954, a Soviet Marine space reconnaissance and target designation system satellite with a nuclear power plant on board. On January 24, 1978, it crashed on Canadian territory, causing radioactive contamination of part of the Northwest Territories. The Soviet side considered the contamination insignificant in contrast to the US and Canadian side, which pointed to the significant nature of the contamination. A total of about 100 radioactive debris fell on an area of more than 100,000 square kilometers. In places of fall of some of them, radioactivity was really significant, up to 200 Röntgen/hour, but the most part of territory was not affected. There were no casualties among the population. Kosmos-954 was equipped with nuclear power plant from which onboard side-scan radar was powered. Maximal lifetime was 135 according to other data days. Kosmos-954, weighing 4.3 tons, was launched from Baikonur Cosmodrome on September 18, 1977. It worked in tandem with its twin satellite Kosmos-952, launched 2 days earlier. Kosmos-954 had been in operation for just over a month when, on October 28, the ground control services unexpectedly lost control of it. The reason for this remains unknown. Most likely, there was a failure of the correction engine. It was not possible to put it into a higher orbit for burial. On January 6 of the following year, the instrument compartment was depressurized, the spacecraft was completely out of order and stopped responding to commands from the control center. Under atmospheric drag, the satellite began spinning with acceleration and declining until finally, on January 24, it entered the dense layers of the atmosphere and collapsed, partially burned, over northwestern Canada. Shortly after the satellite's launch, in November, the North American Aerospace Defense Command, which monitors all satellites and objects in outer space, noticed that it had gone astray and posed a potential threat due to a possible fall to Earth. Intelligence already had information that the satellite had a nuclear power source. The Americans assumed that it was a chamomile type, so the U.S. National Security Council instructed the Department of Energy to prepare for the fall. On December 19, a team was formed on the space debris. In January, the world public became aware that a Soviet reconnaissance satellite with a nuclear reactor on board was in orbit without control and continuing to descend. The Western press discussed when and where the flying reactor would fall. This event, due to its low predictability, was nicknamed Russian roulette. Calculations have shown that the fall will take place on January 23 to 24. U.S. authorities requested information about the satellite from the Soviets, who confirmed on January 14 that the satellite was indeed equipped with a nuclear reactor and that control over it had been lost. In the early morning hours of January 24, the satellite disappeared from U.S. radar screens while crossing the North Pacific. A space object tracking station in Hawaii used its telescopes to track the satellite as it began to fall and burn up in the atmosphere. Almost immediately, reports began pouring in from various places of the fireball streaking across the skies over the Canadian Northern Territories. It became known that at 6:53 a.m. the satellite had entered Earth's atmosphere over the Haida Islands, formerly known as the Queen Charlotte Islands, and had likely struck the Earth's surface near Great Slave Lake. U.S. President Carter called Canadian Prime Minister Trudeau and offered help. The Canadian government accepted the assistance offered by the U.S. authorities in searching for the radioactive remains of the satellite and reactor. On the same day, American specialists arrived in Canada. The headquarters of the search operation was based at a Canadian military base on the outskirts of Edmonton, Alberta Province. The operation itself was codenamed Morning Light after the only evidence of a satellite crash that occurred in the early morning hours. The first phase of the operation was an airborne sounding of the area using airplanes and helicopters. Once the 800-kilometer area of the fall had been defined, the second phase, the search for the remains of the satellite, began. The first object was found on January 26. The Americans received evidence of what are the remnants of the nuclear reactor core. More than 100 fragments in the form of rods, disks, tubes and smaller parts, whose radioactivity ranged from a few milliröntgen/hour to 200 röntgen/hour, were found in total weighing 65 kilograms. In total, more than 90% of the radioactive fission products from the satellite's reactor were collected. The cost of the operation was $14 million. The fall of a Soviet spy satellite with a nuclear reactor and subsequent radioactive contamination of the territory of a NATO country caused a major international scandal. The Soviet government was forced to officially acknowledge the launch of satellites with nuclear reactors and pay compensation to Canada for contaminating the territory with radioactive remains of the satellite. The exact amount of compensation is not known. Various sources list amounts from $3 million to $7.5 million. According to the document Settlement of Canadian Claims Against the Union of Soviet Socialist Republics over the damage caused by Kosmos-954 of April 2, 1981, Canada in its statement of claim assessed the costs of repairing the consequences of the crash as $6,041,174.70 and insisted on the right to recover from the USSR additional unaccounted expenses that may arise in the future. According to the document, the Soviet Union pledged to pay $3 million Canadian dollars in compensation to Canada for all the circumstances that led to the fall of the satellite. The document was signed in Moscow by Canada's ambassador to the Soviet Union, Geoffrey Pearson, and Deputy Foreign Minister Ryzhikov. The Soviet Union also had to give up launching similar satellites for almost 3 years, and made serious improvements to the satellite's radiation safety system. In particular, the design of nuclear reactors on spacecrafts was changed. All fuel rods were forcibly ejected by a gas actuator. As a result of the fall of the satellite, more than 100 radioactive fragments were scattered over the territory of about 124,000 square kilometers, that is about 10% of the northwestern territories of Canada. Due to the low population density of the territory, the population density is approximately 1 person per 28 square kilometers, and the high dispersion of radioactive fragments, the probability of radioactive contamination of people was small. A large number of rivers and lakes also contributed to the rapid absorption of radiation. If you are interested, do not be lazy, give me a thumbs up. And don't forget to subscribe so you don't miss any more interesting videos on my channel. Hit bell to notify me and share this video with your friends. What else interesting things can you add to this video? Write in the comments, it will be interesting to read.